Well, I'm Stefano, and yeah, I'm based in Edinburgh, in Scotland, where I work as a machine learning engineer. My background is really varied because my journey started with studying biomedical engineering, and then from there I moved to more computational stuff. So I moved to Edinburgh for a PhD in computational chemistry, as where I got all my computational background. And from there, it was easy to step on a data science position. So I moved to a financial company to be a data scientist. And from there, I started actually my journey into the ML engineer field. So building infrastructure, creating systems for trading and deployment. And now, yeah, I'm working in Synthesia. What I do is so I work as a ML engineer. So what I do is, again, building infrastructure to allow our research engineer to have an easy life for running their experiments, running the model, and so on. And what we do at the end of the day is to produce avatars from where you can create your own videos. So if you don't have a camera, you can just simply go on the Synthesia studio and create your own video with your avatar. So it's all generative AI, what we do. Yeah, that's in a nutshell who I am. Good question. So, right, yeah, there's been a lot of changes. When I was doing my research, it was a lot of statistics and maths. What we were doing was to try to exploit all the best computational resources in order to simulate how a drug, well, with a given protein, for example. The calculation seems simple on the paper, but it's very complicated because this tiny system have a lot of variables in their dynamics, so computers cannot bear these things, right? So with the usage of deep learning, I could see also when I was doing my research a great improvement. So what happened is that people started to get a better description of this molecule, a physical description of how to exactly tell the computer how the molecule is physically. And this has helped a lot in terms of cutting out a huge amount of computational cost and resources and simulations to run. And from there, well, actually, we arrived today where people are using machine learning to create more sophisticated description that are a bridge between quantum mechanics and what's called molecular mechanics. This means that we can have a more detailed description of the molecules where we're going to simulate, and also better results. So with simple calculation, let's say now, we can get more accurate results than what we were used before. I think the improvement is there. Now there's a lot of hype, like DeepMind as just, definitely you can create a lot of things, but it doesn't solve any problem in real life. So there's still a lot of things to do. Because yeah, AlphaFold just gives you the best description of how a protein could be positioned in space. And it's great because it can give you maybe the more natural pose of a given protein, so you can start a simulation with a lot of information. But I think there are a lot of things to sort out because obviously proteins can move in our body.
Yeah.
A drug could find any possible site to bind to a specific protein, so there are a lot of unknowns. But I think generative AI and deep learning as well, a lot of deep learning and a bridge between quantum mechanics and classical mechanics could be the key for the computational chemist to go. I think generative AI might be helpful in give researchers a better description of molecules or poses, let's say, how the molecules are basically in the space, right? And from there, that could be. I think, yeah, there could be a huge number of publications in the future that are making usage of generative AI to get better results. Again, I think a thorough mathematical thought at the basis of all the publication must be present, because in computational chemistry there's supposition or hypothesis you can do, because physics is physics. It's not like well, the models say this, but you have to prove it.
I see. It will be more common for us to see in the future that more and more publication will go that way?
Yes, of course, definitely. Yeah.
Is there any downside for that, or very minimal?
Beautiful question. The problem of the computational chemistry community is that the progress happens on average, 5-10 years. So if you push something that could make a break change, maybe in 2-3 years time, we could see at every cycle we could see some sort of evolution, better, more accuracy. I mean, the calculations themselves are just a tiny part of the entire process, obviously, but we can improve a lot of fundamental problems in the research for new drugs. Definitely, yes, we can have better answers to specific properties, for example. Obviously, everything with a money mindset, obviously, because it's awful to spend million and million of dollars for some ML when you can do these things with some simple physics. That's what I'm saying, why the computational chemistry community is a bit weird. Just because they have a great sense of physics, so there's sometimes this contrast. But obviously, Gen AI or ML in general is already helping a lot all this research. Definitely, there's no doubt on it. I will be giving a talk mainly on the MLOps field and dealing with big data. So regarding data processing or also model training. And in particular, I'll be presenting something about Apache Beam and Dataflow. So Apache Beam is like a programming language, we'll say. Okay, it's not really a programming language. It's based in Java and Python, but more or less it has its own in the packages. You could say, oh, it's a programming language. And the cool thing of Apache Beam is a unified model. So as soon as you learn Apache Beam and how to use it, you can immediately start creating pipelines. Pipelines for what? Pipelines for example, data processing, or even maybe feature creation. They could even be used for model deployment, for example. The cool thing is that it's fully supported by a great community and also by Google itself. So on Google Cloud Platform, there's this product called Dataflow. I think is one of those great products. Definitely must be in the MLOps tools or in the MLOps engineer's mind. And the good thing of it is that allows you to easily scale up basically infinite number of machines to account for your data processing task. And the great thing is you just need to code with Apache Beam, create your pipeline, make an image, push the image to Google, and run this Dataflow program, let's say. So as you can see, it's pretty easy. It's pretty easy to scale it up. It can deal with an unbearable amount of data. It can also be used for model deployment. So you could even do some kind of real-time or almost real-time inference with these two simple things.
Do you feel like not a lot of people right now know about it?
Beautiful point. On one side, I know just a few people that are using Apache Beam, or people that have considered using it. On the other side, companies like Spotify are using Apache Beam daily, Dataflow, and so on. So I personally think that Apache Beam is a bit of an underdog in the MLOps tools. So that's why I say, okay, it's a good occasion to show people what we can do. One downside that I will show is that the learning barrier to learn how to use Apache Beam, and it's not super intuitive initially. So, but why is that? I think you need, first of all, to understand the underlying philosophy of Apache Beam. So how it works, how it structured all the data, what are the outputs that you can get from each pipeline step. And also have a bit of know-how on how to debug the pipeline itself. Sometimes, and this is a problem on GCP as well, I think, and many people might say, yes, it is. When you have an error on Google Cloud Platform, sometimes it's a bit tricky to understand what the error is about because they didn't give a lot of details. So, so that's the downside. But I think it's a valuable tool, especially if you want to maybe start with your own idea, start with a startup. You could have this tool that's fantastic to process all the data that you have. It doesn't cost a fortune as well. So there are these things to keep in mind. Yeah. Maybe I say this every year. to any kind of interview, and is data ethics or model explainability. I think we are reach a point where we need to think on one side to have more ethical implication on the data that we're using and how the model is using all the data that we're using. We're feeding this model with a lot of data. So what are these data doing, and can we have some ethical guidelines or any possible instrument to help us to guide through what the model does with this data, and on the other side have better explainability for the models we're producing. So LLMs are fantastic, right? But I think we do need to understand exactly how the entire process behaves, why they're so powerful, to what extent we need many data, what means to have many data. So this could be even related to simple mathematical thoughts about throwing up maybe some kind of theory that could explain better what all these data landscape in the LLMs does. So I think there's two sides. I think everyone has to keep this in mind. It's a great point. How I think maybe stop some time to rush for the product, think more about what we're doing with the data in order to avoid possible great human ethical problems. That's it.
The topic ethical AI will be discussed during the event also.
Through them, well, one of them get to know more Apache Beam and what it means really. The second take-home message would be to start simple using Apache Beam to make your ideas more concrete. So if you have some startup ideas in mind, they might be a good valuable tool. And the other take-home message, well, it will be a practical technical presentation. So I hope people will have a flavor of what you can do on Dataflow and mixing up these two products together. I have a great expectation, especially as a participant. I'm very curious to hear what people are going to present. There are a lot of talented people, a lot of value. So thanks to you and all the person that are organizing, because it's such a great opportunity for all of us in AI. And also getting to know, well, on one side, getting to know a lot of people I just met online since I'm here, not in Italy. So finally we can meet up. That would be great. And on the other side, get a flavor of what the, I don't know if it's just related to Italian people, maybe what our talented Italian are doing in AI, but also having a full picture of what's happening in the AI, maybe something I missed. So that's high expectations. There are so many projects. This is a bit of a question that I don't know exactly how to answer.
Name one person.
Name one.
Yes, name one person.
Let's go for simple MLOps courses, right? So that's a good project. I do want to be 100% into. I'm already in contact with all the entities, so it would be nice if I could start giving something that I think would be great for, especially for a lot of people, a lot of students or people who want to do a career change. So just to understand exactly why there's so much hype on MLOps, what it means, how to start, because it's a never-ending journey, unfortunately, I say.
I see, and the course will be online.
Yes, of course. Yeah. It will be everything online. No, fingers crossed.
Collaboration effort.
Good point. There might be a collaboration effort actually, but still a lot of things to decide.
Thank you so much for your time. And I know that the clock is running out. That's the shitty thing about Zoom. It's great, but it's a capitalistic product. So, I don't know if you noticed, but the speaker had 45 minutes of the time allocated.
Yes. How is 45 minutes presentation?
Including Q&A.
Including Q&A. All right. So
I think max you can take like 1-2 person.
All right. So about 35 and 10 minutes questions, something like that.
And if there are more questions for you, I think I can just take the question and deliver them to you later by email or whatever. But yes, we do have that time constraint. We literally running a marathon. Is it
excellent?
Thank you so much for your time.
Thank you. Thanks very much. We can't say anything. I actually have to renew my passport, so we can't say anything. No, but great. Thanks very much for your time, Tao.
Yes, thank you
Cheers.
so much. Have a
Bye.
nice day. Bye bye.
Cheers.